Good morning. Good morning, everyone. So, this is Uma Maheshwari. I'm working as assistant professor in Hindustan Institute of Technology. Today, we are going to see about data warehousing models and operators. So, in this video, so what is data warehouse? What are the data warehouse models and operators? Okay, we are going to see the relationship between two models, and what about the star schema and the snowflake schemas, and what about cubes, so in multi-dimensional modeling. And also we are going to see some of the operators in this model. First one is slice and dice, second one is roll up and drill down, third one pivoting, and some other operators we are going to see. Okay, so first one, multi-dimensional data. So what is multi-dimensional data or multi-dimensional modeling? And yes, we are going to see what is measures, what are the dimensions are there. Here measures are the numerical data, yes, any data that was being tracked in business, that was the data can be analyzed and examined. It may be your historical data, it may be your current data that was analyzed for your future business analytics. For example, you can take it as a stock marketing analyzing. And obviously you are going to do a business, you are going to make a partnership in a specific business, means you are going to analyze your business data, previous data. We call it as a historical data. Next one is dimensions. So what are the parameters of that? So while considering a specific business, okay, so it was a maybe it was a static data or dynamic data. And yes, we are going to see some of the tables. So for example, an analyst want to view the sales data. Here we are going to take a sales data, so in an industry or a business or whatever it is, sales data. So by location, time, and particular product, you're going to see the location, that is geography, time, and the product. Am I right? So yes, so he can see your relational table, right? Sales by product line over the past 6 months. So we can take the past 1 year. You can take a quarter. Quarter means 6 months is the half, right? So 3 months you can take, 1 month you can take, or 6 months you can take for your analysis. So here we are going to take sales by store between the year 1990 to 1995. Okay, so yes, so what are the dimensions here? Yes, here the dimensions means attribute. So if you are taking an Excel sheet, means you consider the first row in your Excel sheet, that we call it as attributes. Here we call it as a dimensions. Okay, so key columns joining fact table. So the dimension table contains product code, time code, store code. So, what about the sales? What about the quantity of your product? Yes, these are the dimensions. Here, specifically, uh, the sales and the quantity, these are the numerical measures. Am I right? It may change, the value, the sale value, and the quantity may be vary. Am I right? So the product code, time code, and the store code. So yeah, time code also change, but we are considering about the numerical measures, means we concentrate on sale and the quantity, right? And yes, so it's a, what is a multidimensional modeling? Yes, structuring your data around the business concepts for analyzing. Am I right? So, entity relationship model describes the entity and relationship. So, what are the dimensions we are having? So, what's the relationship between two-dimensional table? So, that is entity and relationship. So, here multidimensional model describes the measures and the dimensions. Okay, see the previous slide, the fact table for measures. fact table for measures. So how many datas you are taking, how many actually the dimensions are same, but how many datas you are taking, you are going to see. Okay, so next one, dimensional modeling. So the dimensions are organized into hierarchies. For example, consider a time dimension. Okay, so you are considering the time means in which day. Okay, so in which day, which time. So hierarchy means you are taking a lower category to higher category. So day, week, quarter. So day, week, quarter. Okay, here you can say it is quarter is a 2 week or 3 week. You can replace the quarter as month. So day, week, month, next quarter, that means 3 months, half means 6 months, afterwards you consider it as 1 year. So this is a time dimension hierarchy from lower category to higher, lower higher hierarchy to higher hierarchy. Okay, so next, product dimension. So yeah, time dimension we seen, right? Product dimension, so consider a single product. So what about the product line and the brand of the product? Okay, so see this, the dimensions having attributes. The first one, consider a time. Okay, we are generally considering time, right? So basically, in which date the product is sold, in which day the product is sold. So time means we are going to consider date, month, year. So still we are going to describe the time means you can use a geographical time also. Next, store means, so what are the attributes you can include in store? Guys, we can extend, right? So I need a detailed information means we can extend our attributes. So here the basic thing is store ID. So where your store is located, that is important, right? So we are considering store city, state, country, region. Okay, and also you can include a store branch. Okay, so under which branch, so branch name also you can include. It's okay, so you include more attributes, right? Next, dimension hierarchies. Yeah, guys, I told about, right? So from lower dimension to lower hierarchy to higher hierarchy. So here see, the hierarchy of store dimension. First, how many stores are there? Next, you're considering district, region, total. So for example, you're marketing your product all over India means, so how many stores all over India? Okay, so guys, you're going higher hierarchy to lower hierarchy. So yes. So just see this lower hierarchy, how many stores you are having. Okay, so just collect those stores in district wise. So in how many districts your stores are there? Okay, next, region wise. Okay, so where, in which regions, like you're considering south, north, southeast, northeast, southwest. Likewise, you are distribute your regions, and finally you are conclude to total. Okay, so guys, why we are going for hierarchy means, suppose I'm going to consider what is my profit for a previous month means, I'm just calculate the entire sales data from each and every sale stores to the total regions. Am I right? Yes. Next, product dimension. So, see, product dimensions. What are the products I'm having? Okay. So, which brand the products are? Okay, so next, so from which manufacturer I'm getting the products. So whether I'm owning the manufacturer, I'm just manufacturing the product, no, I'm just getting from other manufacturer, so I need that details also, right? So products, what are the brands, so from which manufacturer you are getting, and finally you are getting the total products. So manufacturer name, so these attributes are extending. For example, manufacturer ID, manufacturer name, manufacturer address like city, region. So we can extend our attributes. So next, yes, schema design. Basically, what is a schema? So we call it as a structure. Schema is a structure. How you structure your dimension, how you structure your relational table. Okay, so here most data warehouse uses a star schema to represent multi-dimensional model, like uh, a schema design having a fact table and dimensional table. Okay, so we are having two tables to design a schema for star. We are having two tables, a fact table and a dimensional table. So here, dimensional table means we are having the attributes of each and every dimension. But what about the fact table? The fact table connects all the dimensions within a multiple joint. For example, each and every dimensional table having a primary key. Am I right? Each and every dimension having a primary key. Okay, so these primary keys are collected in a table called a fact table. Am I right? So the link between the fact table in the center and the dimension table in the extremities form a shape like a star. Okay, so the dimension tables and fact tables are connected together to form a star like a structure, that we call it as a star schema. Here you can see the structure of star schema. See, so in center you are having fact table, so on the corners we are having dimension table. Okay, so the key value of each and every dimension table must be stored in a fact table. Yes. Next, see the example. So we are considering sales, right? Okay, so inside the sales, what are the dimensions we are having? Product, period, and store. Yes, so what are the primary keys? Product code, or you can consider as product ID. Next, period code, that means time code. Okay, so next, store code, or you consider it as a store ID. So these three are the primary keys. It can be stored in a fact table called sales. Okay, so guys, why we are storing these keys in a fact table means for easy retrieval of our data. So using primary key only we are communicating our tables, right? So we can easily retrieving the data, we can store all the keys in a fact table. See a example data. So the product code, see the product code, see the period code, and also see the store code. So the three primary keys are stored in a fact table called sales. So how many units sold, how many dollars sold, how many dollars cost, the cost of the individual product. So these things are stored in a fact table called a sale. So the star schema, so it having a one to many relationship between dimension table and fact table. A single fact table with a detail and a summary data. So a relational model with a one to many relationship between a dimension table and fact table. Okay, so a fact table contain a detail and a summary of a data. Here the primary key has a key column per dimension. For example, you are having 5 dimensions that was attached to a fact table means, so 5 columns be in your fact table. So each dimension in a single table, that is highly denormalized. So what are the benefits of your star schema? So the mapping between the business entities, we are easy to define the hierarchies. And one more thing, we are easy to grab our data easily, right? So using our queries. So yes, it was low maintenance and very simple metadata. And what are the drawbacks means? Summary data in a fact table yields poorer performance for summary levels. That was suppose, just consider an example. We are having 10 dimensions, means the 10 dimensional key values are attached in a fact table. So you are adding the dimensions to your fact table, the column also adding, right? So we are having a huge summary of data in a fact table. So that is a little bit tough to handle. So next, need for aggregates. So the size of the typical table, so time dimension, 5 years into 365 days means how many columns we need, how many datas we need to add. So store dimensions, so 300 stores, guys. One thing, so we are adding the data one by one, the column or the row also increasing, right? So the product dimensions, 40,000 products in each store, right? Maybe. So it will increase, right? So your updating your products in your store. So maximum number of base fact table records 2 billion. Okay, the lowest level of details I'm saying, like for example, time means you're considering day, right? So it will extend up to 2 billion data. So a query involving one brand in all stores for 1 year, one brand for all stores in 1 year. So we can summarize over 7 billion fact table rows. Okay, it's not a column. Fact table rows means considering your one each and every record of your product. So aggregating fact tables, here aggregate fact tables are summarizes of the most granular data at higher levels along the dimensional hierarchy. So see, what are the hierarchy levels? First, you consider a product category. So hierarchy levels means the product key category, the product key, product category, and department. So these are the hierarchy levels. So multi-way aggregation means category and month, the data values at the higher levels. So fact consultation schema, see this, consider a store key. The store description means we are going to see city, state, district id, region id, and a regional manager. Okay, so fact table having a store key, product key, and period key. We are having 3 dimensions, right? Store, product, period. Okay, in time dimensions we are having a period, year, quarter. So district fact table and regional fact table. So aggregate fact tables, so the product base table, sales fact, store, time, it's a one way sales fact. So you see aggregate fact tables, right? Base table, sales factor. So we are having product key, time key, store key, so unit sales and sales in dollars. That means how many profit we are getting. So that's a base table for sales. So here is a category. So what about the category? Under the region we are having time key, store key, unit sales, sales dollar, category key, category, and the department we are having. So next, families of stars. So more than one fact table and how the dimensions are connected with each and every fact table. So we are having more than one fact table that was connected with different dimension tables. So that is called as families of stars. So basically we call a star schema, it has, yeah, see the previous slide, star schema it has. So in the corners of the fact table the dimension tables are connected. It may be a 3 dimension table or 4 dimension or 5 dimensions. Okay, so next one is snowflake schema. So yes, it is a type of a star schema but a more complex model. So snowflaking is a method of normalizing the dimension table in a star schema. The result is more complex queries and reduce the query performance. Next, yes, see this, we already seen the star schema, right? Here the same thing, snowflake schema. Product category, inside the product category we are having a brand key, brand name, and a category key. So see the product attributes. So inside the sales fact table, we are having a product key, time key, and customer key. Under sales representation, so salesperson name and a key, so territory key and a regional key. Okay, so these are the timing, right, timing keys, and also their hierarchy levels. Snowflaking. The attributes with a low cardinality in each original dimension tables are removed to form a separate tables. So these new tables are linked back to the original dimension table through artificial key. It was also like a hierarchy. For example, product, we are having, right, product key, product name, product code, and what about the brand of the product. So we can extend a separate dimension table for brand. So we need a brand key, brand name, and category key. uh, Guys, if we need to add a new dimension, means we need to include a primary key of the new dimension in the old table and also in the new dimensional table. Consider a brand key. The brand key is present in the new table and also in the old table. You see the category key also that was present in the new table and also in the old table. Alright, so snowflake schema. So see, what are the advantages and disadvantages. So advantages means small saving in a storage space. Here normalizing structures are easy to update and maintain. Guys, we are structuring our table into a small tables. So what's the reason means, while we are retrieving the data from the database, it is easy to retrieve, right, and also easy to search. And what about the disadvantage? Yes, it was schema less intuitive and end users to put off by the complexity. Ability to browse out the contents difficulty. See, for browsing, I'm getting a detail in the same table. So if I extend the dimension, means my query length also be extended. What is the best design here? So snowflake schema or star schema. Snowflake schema is easy to maintain the dimension table because we are having more dimension tables, right? So it was not generally recommended in data warehouse environment. Star schema more effective for data cube. So snowflake schema is easier to maintain and the star schema is more effective for data cube browsing. Yes, we are having more joins in snowflake schema, but in star schema we are having less joins to fact table. So it can be perform good in star schema. See aggregates. So add up to amount for day one. Okay, consider the day one. So see the query. Select the sum of amount from sale where date is equal to 1. So considering the date, the month starting, right? So what are the amount, that means a profit for a single day uh, from store S1 and S3 and S2. Okay, so calculate the sum of amount. So sum of amount, the condition here is date is equal to 1. Okay, so you have to calculate all the amount from this whatever be the store, but for a date one we are need to calculate the total amount. So the total amount here is 81. So 12, 11 and 50 plus 8, am I right? So that is 81. So next, see the next query. Select date, sum of the amount from sale, so which we group by date. Okay, so for example, we are having multiple stores, right? So for date 1 and 2 we are going to calculate the sum of amount. So how many stores for date 1 we are having S1, S2, S3. For date 2 we are having S1 and S2. So we are going to group based on the date 1 and 2. So see in the right side, date 1 we are having the sum of amount is 81. For date 2 the sum amount is 48. So another example, select the date sum of amount from sales group by date and product ID. So yes, so we are not considering here store, we are considering the date and also product ID. So for date 1 we are having product P1 and P2. For date 2 we are having a single product P1 only. So the amount be splitted, right? The 81 is splitted into 62 and 19 based on the product P1 and P2. Okay, so this is roll up and drill down. Okay, so we can say what is roll up and drill down. So the operators are here, sum, count, maximum, minimum, median and average. So we see numerical measures, right? Numerical measures means the sales under the amount, that means the profit of each and every day sale. And next the operator having class, and dimensional hierarchy we are having average by region, maximum by month. So here is a data cube, product ID, store ID and amount. Okay, so here multi-dimensional cube, we are having the product and store ID alone. What are the products? So in which store the product be sold? So these are the 2 dimension. So 3D cube. Okay, 3-dimensional means we are seeing the product, store and the day basis. Okay, so guys, you can consider it as a day basis, weekly basis, month basis, quarter, or 6 months, or we consider it as an year. Okay, so the day. Next we are going to see a example of a cube. So what are the dimensions we are having? It's an example for 3 dimensions. The first one is store, second one is product and third one is time. So in time we are taking a week. Okay, so what are the products we are having? Bread, soap, cream, coke, milk and juice. And what are the stores? That means region of a store. The dimensions we are having time, product and store, right? Attributes for each and every products are defined. So the hierarchy means the product, the brand, day, week, quarter, store and region of a particular store. So see, for a particular day, Monday, consider it as a Monday. So Monday, what are the products, the sale of a particular products or quantity of a particular product in a store, in which region? For example, Los Angeles or whatever the region may be. Okay, so next one is cube aggregation. That means you are rolling up. So what is a roll up? So roll up is a climbing up a hierarchy. That means I told, right, a low hierarchy to a higher hierarchy, that we call it as a roll up. And drill down means it is opposite to roll up. Okay, so let me see with some example. Yes, roll up means climbing up a hierarchy from daily to monthly sales. Day to monthly sales. See here, the sum of the sale of a particular product P1, S1, S2 and S3, the sum of the sales of S1 and S2, S3. Actually, guys, I'm just taking about the store only, store 1, store 2, store 3, whatever the product may be. So the sum will be 67, 12 and 50. So totally we are getting 129, right? So and also you are calculating the sum for each product. So you calculate for each store and also you calculate for each product. That is a roll up. So here see cube operations for roll up. Day 1 and day 2 for the product P1 and P2. The sale of S2 comma P2. Okay, so you are taking a single product for a sales region S2 for the product P2. Here the sale S1 of the entire product P1 and P2 count is 67. Right, here the sale of entire product and entire store is 129. And see the extended cube for day 1, day 2 up to day n you can calculate for the product and also for the store, for n number of products and also for n number of stores. Aggregations using hierarchies. So hierarchy means whatever the store region and the store country. So region A, region B, guys, we can combine it as a countries, right? So for the product P1 and P2, and also you will be consider the stores S1, S2 and S3. So where the S2 store is, where the S2 store is, where the S3 store is, in which region we are considering. So next one, slicing. Okay, so you are taking a particular dimension from the entire table, from the entire cube. Okay, so for example, product P1 and P2. Okay, so for S1, S2 and S3. So the product P1 and P2 for S1, S2 and S3. Okay, so we are not considering day, right? So everything we are having in our cube. Okay, so we are not considering days, we are considering the entire products of store 1, store 2 and store 3. Okay, see the slicing and pivoting. Store S1, S2 and the sale, considering the 2 dimensions, sorry, 3 dimensions, the product, store and timing. Am I right? So electronic toys and clothing cosmetics. Electronic toys, clothing, cosmetics. See, so electronic toys and clothing alone for the store 1 and also in the store 2. Okay, so here the aggregation roll up and aggregate summary data to the next higher dimensions. Example, total sales by the city or per or the year. So the total sales by region or year. So we are considering the city, but here we are considering the region. So next, drill down. Okay, so next slice defines a subcube. So roll up means we are climbing up a hierarchy. Drill down means we are opposite to roll up. So what is slide? It extracts a subset of data from the cube by fixing a value of one of the dimension. Dice means subsets a specific cube by fixing a set of values. Next, pivot. It rotates the data cube to view the different perspectives. So these are the operators we are seeing. Actually, we seen roll up, drill down and slice. Am I right? So example, slice means sales where city name is equal to, I'm considering a specific city and a specific date. Okay, so I'm just applying a condition in our table. And calculation and ranking, example, top 30% of city by average income. So which city having the highest income? So next, visualization operations are pivot and the time functions are time and average. So in which time we are getting the highest sale. Okay, so what is the average of a particular sale in which timing? So we are applying two conditions, the time and average here. Okay, so yes, you got the view of what is star schema, what is the snowflake schema, right? What about the multi-dimension, what about the 3D dimension? So compared to star schema and snowflake schema has an extended dimension, snowflake schema have a limited dimension. So everything we specified in a fact table. That means we have a huge columns in our fact table. And which one is better means, so we can say it as a star schema or it was a snowflake schema. And we seen the operations for the schemas for the cubical structures. So what is roll up, drill down, slice? So we are applying the queries with the specific conditions. So whether you are extended your conditions, whether you are compressing your conditions. So that's a difference here. So okay, so we will come with some other topic. Thank you.